Hi. Hi, everyone. And thank you very much, Yvette, for making this work for us today. Um, I'm really excited to be here to talk about um, some work we're doing on some Neoproterozoic fluvial rocks in West Avalonia, exposed in the Avalon zone of Newfoundland, looking at syn deformational sedimentation and revisiting the Lilly unconformity. All right, so we're looking at the Signal Hill group here. So it's the youngest part of the Neoproterozoic stratigraphy of the Avalon zone here in Newfoundland. We're particularly in the eastern subzone of the Avalon zone in Newfoundland. And so here, like in many other parts of Avalonia, we've got this main arc between about 640 and 585. And that's followed by a period of waning volcanism and arc adjacent sedimentation. And then around 565, that transitions into progradation, which, is either from foreland basin sedimentation or possibly pull apart basin sedimentation, but a different basin configuration is happening. And this transition in the latest part of the Neoproterozoic within Avalonia is thought to be the result of this enigmatic Avalonian orogeny. Okay, so the Avalonian orogeny really refers to a period of deformation between about 580 and 540 million years ago. According to Van Staal and others, that records the lateral accretion of West Avalonia onto the Gandarian arc, although there are other ideas about ridge trench collisions. Either way, deformation wasn't sort of pervasive and widespread during this orogeny in the same way as, say, during the Acadian orogeny. So the evidence is subtle, and really a lot of it's hidden in the sedimentary record, showing changing landforms and topography related to tectonics. And no one's really looked at that a lot here. Art King in 1990, in the 80s and 90s, looked at this and in a broad sense suggested that the Signal Hill group records progradation from uplift of some mysterious source area in the north of modern north of Avalon, of the Avalon Peninsula, that is. Okay, so that's why we're looking at this, both because it's right outside our windows at Memorial University, but also because they're really cool, interesting rocks, and there's lots of ideas here that are sort of interesting about evolution of Avalonia, but also about how rocks, respond, or how sediment responds to how sedimentary systems respond to deformation. And so the Signal Hill group here is exposed in this broad synclinorium on the eastern shore of the Avalon Peninsula, separated into two synclines, the Blackhead syncline and the Bay Bulls syncline to the south. And they're offset a little bit, so it's kind of strange. And so some of Tom Kalan's students, and particularly Ben Stanley in 2009, suggested that based on the north to south orientation of the different facies and units, that there was probably a blind thrust located right in here. There we go. And as King suggests, there's a progradation here with a lower deltaic succession and an upper alluvial to fluvial to lacustrine succession. So that upper part is really only exposed in the Blackhead syncline. The other thing is that this Gibbet Hill formation kind of thins to this point and then thickens considerably down into the Bay Bull syncline. And so, that was suggested as evidence that, between during this delta progradation, there was actually blind thrusting going on as well. And that's something that my student Santiago Cerno is looking at. You can see his talk at GACMAC, or I guess it's going to be a poster. Anyway, we're going to look farther up in the stratigraphy at something that's a little more well known, and looking at syn deformational sedimentation going on in the Flat Rock Cove formation here, braided fluvial knobby hill overlain by the alluvial fan strata of the Pecos Brook formation. It's located up here in Flat Rock. Okay. And so here's a map of Flat Rock, and what we have, the main thing here is this Flat Rock thrust that brings rocks of the Conception group, around 580-ish, up against rocks of the Signal Hill group. And the Signal Hill group has its own complexities because we've got folding of the lower parts. This is the Gibbet Hill, Kitividi, and Cuckold. This is the lower parts of the Signal Hill group. And they've quite clearly been tilted and then incised and onlapped by this knobby hill formation, which is thought to be, here at least the upper part of the Signal Hill group. And so we can see if we rotate these beds, this is looking at this unconformity right here along the coast. This is this section here representing this section. We can see if we rotate these back to horizontal, then this would have to have been folded a little bit. So, between this part of the Signal Hill and the knobby hill, we had folding and, erosion of large parts of the Signal Hill here. And then above that, within the knobby hill itself, we see multiple growth sequences between 1 and 2 here. We see evidence that things sort of subsided a bit, perhaps. And then between 2 and 3, we see evidence again of tilting and erosion. And so each of these is sort of recording, cycles of fluvial aggradation, punctuated by periods of renewed uplift, essentially. And so it's pretty cool when you reduce the levels of abstraction here by looking at outcrops. We can see these, the mean paleo flow is sort of to the south. And what we see when we look closely, we're looking at the upper growth sequence. We can see the lower part is quite gravelly, and it contains a lot of these upstream accreting bars. Basically, if you can think of basically sort of smearing gravel onto areas wherever you can in the mid-channel, like along diffluences, but otherwise these are very high energy streams and probably quite shallow too, and very straight. When we look upwards in the stratigraphy in this growth sequence, what we see is things becoming more sandy, but also we see a lot more lateral accretion, which shows things becoming more sinuous and gentle. Overall, what this shows is a gradual decrease in slope, which is kind of what we'd expect if we go through periods of uplift and erosion. Very cool. So looking now at the contact between the Knobby Hill and the Pecos Brook, it's essentially a conformable contact, but we see a sharp change in facies from this braided fluvial stuff below to more sheet flood dominated deposits and sort of lacustrine playa deposits above. Okay. So when we look more closely at the Knobby Hill, what we see is a southward fining from very coarse-grained debris flow material up near here. By the way, this is the Lilly unconformity, or where it's exposed. And when we look south, we see things that are finer. We see these little varvy-looking lacustrine layers with water escape structures, and then these more distal concentrated sediment gravity flows with some sheet flood deposits in between, right? So essentially, this is consistent with a alluvial fan with its apex up near where the Lilly unconformity is. Okay, so yeah, and when we look at the stratigraphy here, what we see are sort of repeating hierarchical boundary services, which is consistent with the avulsion of lobes and lobe complexes against, along an alluvial fan. And so let's go up now to this apex, basically where all of the fluid and sediment drainage would have been coming in and fanning out from that point. And this is where the Lilly unconformity is exposed. And so this was this is all from Anderson, 1975. And he relooked at this from stuff that Lilly looked at in the 60s. And so what you can see here is we've got a thrust, and on the footwall of that thrust, we've got an erosional unconformity between folded rocks of the Drook Formation and the Pecos Brook Formation. And so, age control is a problem, but what this shows is that we had sort of uplift of parts of the Drook and deformation of the droop, um, and erosion and onlap of stuff all happening during the Neoproterozoic. And so this was sort of the evidence of Neoproterozoic deformation that we see. And this is really sensible, actually, for an alluvial fan. We don't know the latest timing of the motion on this fault, but it's thought that that sedimentation here is related to faulting. Okay, so let's take a closer look now. We're revisiting, by the way, the Lilly unconformity, this time using a drone. And so what you can see, basically is what they showed. Here's your fault zone with a duplex for Muse is sort of between the age of the Pecos Brook and the Drook. And yeah, this is definitely an unconformity. But more than that, what you can see, like the Knobby Hill, is growth sequences that record, erosional unconformity and readjustment and onlap at a lower angle as the floodplain basically readjusts to deformation. So that's pretty cool, and I think that backs up the idea that that sedimentation here is related to faulting and why we have the Drook adjacent to the Pecos Brook here. So let's put this all together now. We've got 6 growth sequences between the Knobby Hill and the Pecos Brook. And so the Knobby Hill is sort of thought to record, and the paleoflow is also to the south. So we're looking kind of southish here. And so this is oriented, in the proper orientation. But really what these growth sequences in this Knobby Hill record are, axial flow along an incipient fold and readjustment of that floodplain as the fold, it first steepens and then shallows and then steepens again. And then, I think we see a direct relationship between the flat rock thrust that then comes up, slightly later and deposits these 3 sequences within the Knobby Hill. And that contact that we saw, well, that's actually the 3rd sequence onlapped by the 6th sequence. So there is some possibly some significant amount of time there as well. So that's very cool. Okay, now just sort of a little bit of discussion of what's happening more regionally. So as we go to the south from Flat Rock to the Blackhead Syncline, now age control again is a huge problem here, but potentially we've got correlative rocks, or at least time equivalent rocks, that record lacustrine sedimentation and therefore subsidence. Okay, so we've got uplift happening in Flat Rock and subsidence in Blackhead. And so what that seems consistent with is sort of a foreland setting, and more specifically where we've got evidence of blind thrusting as well, sort of a piggyback basin. So according to DeSales and Giles, this would be in the wedge top part of the foreland basin. And here's a good example. I mean, not the broader tectonic framework, but just looking at things at the same scale in the Avalon versus in the Po River Valley on the margins of the Apennines, where we can see, very similar facies patterns forming because of thrusting to the north, or I guess in this case is to the south, and subsidence, and then blind thrusting. And so there's sort of this like loading and subsidence cycling within these piggyback basins with blind thrusting. I think it's very consistent with what they're seeing in the Avalon. Okay, and so that might have some implications, for the Avalon orogeny, but this is all very much work in progress. Thank you very much, and yeah, I look forward to questions and discussion. Thank you very much.